Revisiting our learning objectives, we learned that the average normal stress is equal to R per A with units of newtons per meter squared, or Pascal, and this is maximized at theta equals 0 or 180 degrees. The average shear stress is equal to the transverse component of the force per the normal area with units of newtons per meter squared, and this is maximized at theta equal to 45 or 135 degrees. To determine if an axially loaded member is in tension or compression, we found that when the average normal stress in a member is positive, the member is in tension, and when the average normal stress is negative, the member is being compressed. To determine the bearing stress in an axially loaded member, we divide the force by the bearing area, which is the thickness of the member times the diameter of the bolt hole. To determine the shearing stress, we divide the force by the shearing area, and this also has units of newtons per meter squared. The biggest takeaway from this lecture should be that the stress in a member can be determined by first finding the force applied and then finding the area this force is applied to.